So using the same systems, when we know what the results are, if I rewrote A as an augmented matrix, I would do 1/10 row 1 and get, the results I see there. I would do row 2 minus 4 times row 1 and get this result right here. And here's where we have an issue. On this side right here, I have a row of zeros. And what I have is basically telling me that 0x plus 0y equals 0, which makes sense. Basically, having a row of zeros to the left of that vertical bar means that all the variables have canceled. And if all the variables have canceled and I add them together, which means there's nothing in their places, then I end up with nothing. Well, that's a true statement. So that would tell me infinitely many solutions. So for B, again, we'll start with the augmented matrix as we had to convert it to this, and we use the augmented matrix. But with what I have here, I want a 1 in this position up here, so I'm going to take row 1 and multiply it by a third, divide by 3, whichever one I say. And I end up with this. I want a 0 where this -6 is. So yes, if I add 6 times row 1 to the new row 1, this one right here, to row 2, then I would get that 0 where I need it to be. So row 2 plus 6 times row 1. But when I do that, though, -6 plus 6 is 0. 4 plus 6 times -2/3 is the same thing as 4 plus a -4, which is 0. And 6 times 4/3 is 24/3. 24/3 is 8. So if I do 5 plus 8, I get 13. Well, what I have here on the left-hand side is that row of zeros again. So I have 0x's plus 0y's equaling 13, which means 0 equals 13, because I have neither x's nor y's equaling, and totaling together is 13. So I have nothing equals something. That's no solution.